Hey, hopefully I can get this video to work. It's going to have to be a quick one, under 5 minutes. So let's get started. This first slide is basically just a reminder of how to do regressions and the review steps. We've done lots of regression lessons, so I'm actually not going to do the regressions. I'm just going to kind of fill in the answers for you and talk about the questions. All right, question one. This one says the velocity of a pendulum is measured by a group of university physics students. The results below are average velocities of 20 identical trials. They give you time. Time is always kind of our x. They give you velocity, velocity being our y. What would be an appropriate regression model to use for this situation? Given that they gave me context, they told me what was going on. They said there was a pendulum swinging. I'm going to use the context instead of the data to decide on what type of regression I want to do. For this question, I would want to do a sinusoidal regression. The reason being is that my data should go up, down, up, down, up, down, because the velocity should always get faster, then slower, then faster, then slower, depending on how that ball is moving. A pendulum is like a ball in the middle on a string that you pull back and let go, and it swings down and back and forth and back and forth. That would get faster, slower, faster, slower, faster, slower. That would be a sinusoidal regression. Create an equation. So to create this equation, you need to put those into your L1 and L2 and then do a regression. When you do that, so you need to do a regression, you should get, and I'm just going to round to the nearest 10th, 3.6, actually I'll round to the nearest 100th, 5, and then sine 1.30x minus 0.03, and then plus 0.10 when you round it. What is the period of this situation? When you go to calculate the period, you want to do 2 pi divided by b. That's what your period equals. When you put that calculation in, use the entire b value. Don't just use this rounded value. Use the entire thing. So in 1.302119015. If you put that in your calculator, you should get that the period is 4.83. D, when will the pendulum first have a speed of 2.5? A speed of 2.5 means this is a y value. So I need to graph my sinusoidal function, this guy, in y1, and then this guy as y2. Then you want to hit second trace intersect. Hit enter, 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 and it should tell you that x equals 0.57. That's the time, the first time that you have a speed of 2.5. Using your equation, what is the pendulum's maximum speed? To find the maximum speed, you go second trace maximum. You're going to go left to the maximum, right of the maximum, and you should get 3.74, I believe. Awesome. This one, the water levels of a particular bay in eastern Canada. So when we're talking about water levels always rise and go up, go down, go up, go down as the tide comes in and goes out. So that means this would be a sinusoidal because it's a repeating pattern, right? The water gets high, low, high, low, high, low. Your model, when you put this into your equation, this should be your list 1. This should be your list 2. I'm just going to round it. Should be y equals 1.12 sine 0.32x minus 2.22 and then plus 1.79. That's the rounded numbers. I just don't have room to write them all. What is the average? Anytime you read average, that's your D value. So in this case, it's 1.79. That's the average depth of the water, my D value. What time of day is the water deepest? I'd want to go second trace maximum, right? Because it's the deepest. If you do that, you should find that the deepest point is at 11.67. Awesome. This last one, I'm just going to write down the answers. You should get the A is that's the highest and lowest points of the blades from the center of the windmill. For B, the amplitude is the A value. The period is 2 pi divided by B. And the range is this. It's the height, negative 1.